Alright, Eric, there's only like 3 things you need to know on how to use your calculator. It's really easy. Alright, let's graph the function x squared. You know how to do that, hopefully, or x to the 5th x squared. Alright, then you got a window. I hope you know how to set the limits. And then Samuel Hahn showed me this cool thing called zoom fit. That's pretty awesome. Alright, now the main thing you want to use is this button right here. You see how it says calc right there? You probably can't see it because my webcam sucks. So you go to second, calc, and then everything that's amazing shows up right here. You can find the zeros, the minimum, the maximum, the intersect, the dy, the derivative at any point, or the integral of any function. So let's start off with a value. Alright, so you plug in a value. You want to know a value at some point. Let's say you want to know what the y value is at 2. Crap, there's a freaking shadow. Okay, nothing I can do, but that says x equals or something. Okay, so you put x equals 2, and then you get a y value, and it says y equals 4 right there. You probably can't see it. Alright, and you can do that with any value. You put in 5, you get 25, whatever. Alright, let's go back to the calculate thing, right? Where everything that's magical happens. Alright, and then to find a 0, you do the exact same thing as value, but you have to set your left bound and right bound. So here's your left bound. We know there's a 0 at 0, right? So we got to put at some negative number as the left bound and some positive number as the right bound for where the 0 is going to lie. So we're going to put -1 as the left bound and +1 as the right bound. And then you see those numbers up there, that's where your 0 is going to lie, and boom, there's 0 right there, right? So you have to make a guess. Let's make a guess of 0. Hit enter, and it's going to tell you the 0 is at 0, 0. Boom. Alright, that's pretty easy to understand. Minimum, maximum, you do the exact same thing. You set the parameters, and then you guess, and it'll give you where the minimum or maximum is. Intersect. Alright, we need 2 curves. Let's make a y equals x graph. Whenever you see how these 2 things are highlighted, Eric, that means it's going to graph both those graphs. Alright, so let's go to zoom fit one more time. Alright, and the intersection is going to happen somewhere right here, right? So let's go to calculator again, go to intersect this time. Okay, we know that they're going to intersect right there, right? So we want to put this thing, you see that thing that's moving around? That's like a target sign. Alright, you want to put it past where the 2 lines intersect. Because they intersect right here, I put my target right there, alright? Because they're going to intersect as they come from here, right? So you go, so you want to put it past it for each one, and then this one's past it too, past here. Alright, and then I'm going to guess 0, because it looks like they intersect at 0. You guess 0, you hit enter. Can you just put on my bed, please? Alright, and that's it. Alright, and then if you want to find the derivative, you go to the derivative dy dx. You just put in whatever, oh crap, you can only do the derivative and integral of one graph. So you want to unhighlight that graph. So only we're going to graph the x squared graph, if that makes sense. Okay. So we're going to go to zoom fit one more time. Once again, zoom fit. Alright, we're going to go to calculator, go to derivative. Okay, we want to know the derivative at any point. You just put in the number, boom, gives you the derivative at that point. The derivative at 2 is 4. Alright, that makes perfect sense, right? Let's go to integral. Alright, so you have to set the lower limits and upper limits one more time. So let's say you want to find the integral from -1 to 2. That's all you have to put in, and it gives you the integral, the area of the integral right there. And the integral is 3. Okay, now let's say you want to find the area between 2 curves, right? Let's say you have these 2 graphs, right? You can't take the integral between 2 curves like this. This calculator won't read it. If you do want to do that, it's a little more complicated, and I actually don't know how to do it. So what you do is you do what we learned in calculus. Makes sense, right? you find out who's on top and who's on bottom and subtract the two functions. So let's go back to the graph, who's on top, who's on bottom. Let's say you want to find this area right here. You see this? How this is on bottom, this is on top, to find the area in the middle there. So we're going to find the integral from 0 to 3, let's say, for this thing right here, right? So we got to subtract x from x squared because x squared is on top. So minus x. And we don't want to graph this because we can only take the integral and the derivative for one graph. So then we go to calculate integral from 0 to 3, and boom, that's the integral between the two curves right there. X squared minus x. Does that make sense? Alright. There's one more thing that you need to know about this calculator, and that's how to graph the derivative. So what you're going to do is you're going to hit this button right here. It says math. Okay, and then you're going to go down to n derivative, and then you're going to put in the function. Now you can write this function right there and put it right there, or you can do a little cool technique by going right here, this button right here, variables, and then at the top you go to the y_vary, then you hit 1 for function, you hit y1, okay, and then now the y1's right there, and y1 is the function of this. So this whole thing is acting like that. Then you hit comma, and you put x, comma, x, in parentheses, and then let's get rid of this graph so we only see the derivative. And we're going to go zoom, fit one more time. It's loading. And there's the derivative of your graph. If you're wondering why I keep saying zoom fit, is because if you look at a graph normally, let's say 0 to, oh crap, 1 negative to 10 to negative 10. Alright, and you graphed x squared normally, your graph would look like this, right? But you see how it has all this extra space right here? We want to get rid of that. So you hit zoom, and then you go to the bottom. I just hit up so it goes to the bottom. And you see zoom fit right there? I just hit that every time. And it makes your graph look pretty. You see that? Alright, tell me if you have any questions. That's it.